Hello everyone! This video is about the measures of variation. The learning outcomes of this lesson are explain the meaning and function of the measures of variation and distinguish the measures of variation. The measures of variation is also termed as the measures of spread, the measures of dispersion, or it can be the measures of variability. It indicates how spread out a group of score is or how varied the scores are. It enables to know whether there are extreme values or whether the values are very close to each other. There are several types or several measures of variation, but we'll be dealing with the very basic one or the most commonly used. So first is the range, next is the variance, and the standard deviation. Although in statistics you might encounter other measures of variation such as the mean absolute deviation, the quartile deviation, the percentile range, or the coefficient of variation. The range. The range is the most simple measure of variability. The formula for the range is equal to the highest score minus the lowest score, or it can be represented by R is equal to HS minus LS. The variance, on the other hand, it has two types of variances. First is the population variance, and the next is the sample variance. So when we talk about population, of course, you have to take the entire population, while the sample is only a portion of that population. Okay, the formula for the population variance is sigma squared is equal to the summation of x minus mu raised to the power of 2 all over n. While the sample variance, s squared, is equal to the summation of x minus x bar raised to the power of 2 all over n minus 1. The differences between the two are, first, the symbol used. In population variance, we're using sigma squared, while in sample variance, we're using the s squared. Another term or another symbol used is for the mean. For the population variance, it's mu, while for the sample variance, it's x bar. And lastly, the difference on the denominator side, since in population variance, it's only n, while in sample variance, it's n minus 1. The standard deviation, we also have two types, just like the variance, because they are somehow related. As you can see on the formula of the population standard deviation, so it's just the square root of the variance, or the square root of the summation of x minus mu raised to the power of 2 all over n. The same thing with the sample standard deviation. So our s is just the square root of the sample variance. So the square root of the summation of x minus x bar raised to the power of 2 all over n minus 1. Or you can simply have this formula to look it easier. So once you're required to solve for the variance first, so the next thing that you're going to do with the standard deviation is that you'll just get the square root of the variance. So our population standard deviation sigma is equal to the square root of the sigma squared, which is the population variance. The same thing with the sample standard deviation. S is equal to the square root of s squared. Now let's proceed to the computation so that you can apply all those formulas that we just had discussed. Same situation as what we had in the measures of central tendency. So here it is. The grades of Anna in 5 subjects are 88, 79, 90, 88, and 95. But the question this time is find the range, the variance, and the standard deviation. Okay, let's start solving using the formula of the range. So the range R is equal to the highest score minus the lowest score. Okay, as you can see with our scores, the highest is 95 while the lowest is 79. Okay, so substituting in our formula. Oops, we have to use the brush. Okay, so it's 95 minus 79. And the result is 16. Next, let's have the standard deviation, the variance rather. So let's have population variance. We'll just use the population for our assessment class to have a simpler solution, or this is the one required based on our textbook. So the population variance is equal to the summation of x minus mu raised to the power of 2 all over n. For us to get the value of the summation of x minus mu squared, we need to make a table. Okay, so first column is the x, then let's have the x minus mu, and then let's square that result, so x minus mu squared. Okay. Okay, please bear with my penmanship as I cannot uh, properly use. I'm still practicing my pen. So let's start with the first score, which is 88. Next is 79, followed by 90, and then we have 88, and lastly, the 95. Okay, previously in our measures of central tendency, we already identified the value of our mean. Uh, it was solved that the mean is equal to 88. So we will subtract the individual score to this mean, which is 88. So 88 minus 88 is 0. 79 minus 88 is negative 9. Next is 90 minus 88 is 2. 88 minus 88, 0. And lastly, 95 minus 88 is 7. Okay. After getting the x minus mu, we need to square the individual result. So 0 squared is 0. Negative 9 squared is 81. 2 squared is 4. 0 squared is 0. And lastly, 7 squared is 49. Okay, since the one required in our formula is the summation of x minus mu raised to the power of 2, so we will get the sum of the x minus mu. So let's have the summation of x minus mu squared. So we need to add 81 plus 4 is 85 plus 49 is 134. Okay, now that we have the summation, we will substitute this value to our formula. Okay, so our variance sigma squared is equal to 134 divided by our n is 5, of course, because there are 5 scores. And the result is 134 rather divided by 5 is equal to 26.8. So this is now our variance, or the population variance. Okay. Lastly, let's solve for our standard deviation. So the population standard deviation, okay, let's have sigma is equal to the square root of sigma squared. So we'll just get the square root of 26.8. Okay, using your calculator, our standard deviation is equal to 5.17. Okay. In case you will be asked directly with a standard deviation without passing through the variance, you can directly write the formula of the square root of the summation of x minus mu squared over n. So substituting still, we have here 134 divided by 5. And then getting the square root, you will end up with the same result, which is equal to 5.17. Okay, as a recap, our range is 16. Our variance is 26.8, which is represented by sigma squared. And lastly, our standard deviation, which is the sigma, is equal to 5.17. Okay, that's it for the basic measures of variation. This is for the ungrouped data. If you want to learn more of the group data, we can have it later, maybe in assessment too. Okay, thank you so much.